Hmm. Hello everybody. Today we are going to start chapter 4, unit 2. Now in this unit we are going to learn about operators and the different kinds of operations that are there in Java. So what is an operator? An operator is a symbol or a token which performs arithmetical and logical operations and gives meaningful results. And what is the other part? The operands. Operands are those which are involved in the operation or on which the operations are performed. So, for example, if we have A plus B, then this is the operator. This is the operator, and A and B, A and B are the operands. Okay. Now, what are the different kinds of operators in Java? Types of operators. So there are basically two kinds of operators. One is the unary operator and the other one is the binary operator. Okay. Now the unary operator means an operand which operates on a single operand. So this one over here, this one was a binary operator, right? This is a binary operator. Why? Because see, an addition requires two numbers or two operands. So that is why it is binary. So you have unary and binary. What are the different kinds of unary operator? One is the the negation or unary plus sign, unary plus operator, and unary minus operator. We will do everything in details. And in binary operators, you have arithmetic operators, arithmetical operators, logical operators, and relational operators. Okay, so let us start with the unary operators. The plus one, okay, unary plus. Now, this is nothing but giving a plus sign to an operator, and it does not change the sign of the operator. This is applied to a single operand. So, like plus A. Okay, so if A equals to 10, then plus A will be equals to plus 10. So it will remain 10. Okay, and if A is equals to minus 10, then plus A will be minus 10. Okay, now so you might think that this is unnecessary, but when you do unary minus sign, then you will realize yes, then unary plus is also there. So this is minus A. So if A is equals to 10, then minus A will be equals to minus 10. And if A equals to minus 10, then minus A will be equals to plus 10. So this unary minus sign basically changes the sign of a particular variable. Just plus becomes minus and the minus becomes plus. Okay. So suppose if I have x equals to 7 and y equals to minus 9, and I have p equals to plus x, q is equals to minus x, s equals to plus y, and t is equals to minus y. So what will be the value of p, q, s and t? So p, q, s, t. What are the final values? Let's evaluate. P equals to plus x. Plus x means plus 7 without changing the sign of 7. So it will be 7. Q is minus x. So it will be minus 7. S is plus y. So it will remain minus 9. And t equals to minus y. So this will become plus 9. Okay. So these are the unary plus and minus signs. Now we will move. Now the next set of unary operators are in unary increment and decrement operators. Now there are two increment and one is the increment operator is plus plus and the decrement operator is minus minus. Now this minus minus and plus plus has a mathematical significance. Plus plus means increase by 1 and minus minus means decrease by 1. Okay, just by 1 and not by anything else. Okay, so now this again has a different variation, is that every plus plus and minus minus can be either postfix or prefix. So prefix, increment. Now what is prefix increment? Okay, I will do postfix and prefix together. I will do the postfix this side. Okay, then you will have a good comparative study. Now see, when you say postfix and prefix, from the name itself you can understand prefix means before and postfix means after. So here suppose x is equals to 15. Okay. Now prefix means the plus plus sign will be written before the variable and postfix means the plus plus sign will be written after the variable. Now what is the mathematical significance of this one? This you have to understand a little. Take for example x equals to 15 we have taken and a equals to plus plus x plus 2 and b is equals to x plus plus and plus 2. Okay, x plus 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 2. Now see here, this is the unary increment and decrement operator, and whatever is the value of this area of this bracket, you add 2 to that. Now what will be the value of A and B? Okay, B is for this side. B is equals to x plus 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 2. Let us see what will be the difference. Now increment, when it is prefix, that means you first increase the value and then you use the value or substitute the value over here. Okay, I am repeating, when it is prefix increment, it means you first add this part. This part means you first increase the value of x and then substitute the value of x. So first increment, then substitute. So what is the present value of x? The present value of x is 15. So the present value of x is 15. So first you have to increase by 1. So after increasing it becomes 16 and then you substitute plus 2. So this is yielding 18. Okay, but when it is postfix, in postfix you see you first substitute and then you increase. So first substitute and then you increase. Okay, so what is the present? So if the same operation is done in the postfix increment, then what will be the value of B? Because x is 15 and then first you substitute. So when you substitute the value, you see what is the present value. The present value is 15, and after you replace it over here, put it over here, then you increase plus 2, which is equals to 17. So you can straight away see how the postfix and post prefix increment has affected the final value of a particular expression. Okay, I will do prefix decrement and postfix decrement. You must know, girls, that the changes are done in the memory space where the variable is saved. So postfix and prefix, let's do. So that means post prefix will be minus minus x and postfix will be x minus minus. So let x is equals to 15. So you have a equals to minus minus x plus 2, and over here you will have, suppose you have x minus minus plus 2. Okay, so this is the operators that has to be evaluated first. So as we know that prefix means first change then use. So x, the value is 15, so minus minus means minus 1, so first change then use. So 14 plus 2, which is equals to 16, and over here is equals to, here first use then change. So x is 15, so first use 15 then change it to 16, and then you increase, so that is 17. So the changed value is not affecting the expression, or that is not being used in the postfix decrement. There are a whole lot of examples given in the book, so you can go through that. I will be explaining all of them after I finish all the operators with you. Then you have binary operators. So let us start with binary operators. Now let us start with binary operators. As we have already discussed, there are three kinds of binary operators. The first one is the arithmetic operator. So that is quite very simple. We do it in our day-to-day life. Addition, subtraction, division, multiplication. Then you have modulus in Java to find the remainder. Okay, so these are the five operators. I will just explain this one. This is known as the modulus. This is known as the modulus or the remainder, and this is for the division. This is for the division. Now there is a difference between the two, so I would like to explain these two. Okay, both are related to division operation, but this one yields the quotient and this one yields the remainder. Okay, so suppose you have x equals to 17 and y is equals to 5. Okay, now you have, suppose you have x by y and you have x mod y. In Java, the division, this slash operator, this yields the quotient of the division. So if you divide 17 by 5, what will you get? 3s are 15 and remainder is 2. So this is the quotient and this is the remainder. So this will be 3 and this will be 2. Okay. I repeat, this gives the quotient, the division operator, slash gives the quotient of the division, and the percentage symbol, which is the modulus operator, yields the remainder of the division. Then you have relational operators. The next set is the relational operators. Next you have the relational operators. There are 6 types of relational operators. Let us discuss all of them. Less than, greater than, less than equal to, less than or equal to, greater than or equal to, then you have equal to and not equal to. So these relational operators, they yield the answer in the Boolean data type, okay, either true or false. So suppose we have two values here. Suppose A is equals to 27 and B is equals to 35. Okay, so if A less than B, so if this is correct, right? So the output will be, this is the output will be true. A greater than B, this is not true, so that will yield a false. A less than or equal to B, this will also yield a true, because A less than equal to 2 means A, the value of A is either less than B or at least equal to B, but not more than B. Okay, then you have A greater than equal to B, so this will be false. A equal to B, this will also be false because the values are not the same, and A not equal to B will be true because their values are not same. Okay, now I will discuss some special examples in the relational operators. Consider a new set of values. X is equals to 39, Y is equals to 47, and Z is equals to 13. Okay, let us see some relational operators. X, and let us take another one. T is equals to 47. Okay, so X less than Y, true, right? Yes. Let us take another one. X equal to Z into 3. X equals to Z into 3. So what is Z? Z is 13. What is 13 into 3? 39. So is 39 equal to the value of X? Yes. So this is also true. Okay. Now Y greater than T. Will it be true or false? It will be false, right? Because the value of Y is same as that of T. So this will yield you false. But if I have Y greater than or equal to T, then this will give you a true. Why? Because when you give equal to 2, so the permissible value of Y is till T. Okay, when I say Y is less than, greater than T, that means if this is the value of T, then the value of Y will be starting after T. Okay, so if this is 47, so 48 from 48. But when you write X is greater than equal to T, so that means it starts straight away from the value of T. So in these two cases are very important examples. Okay, greater than and greater than equal to. Now there is a set of examples in your book, so you can go through that. Okay, now these true values are, true is values are implement in equivalent to 1, and the false values are equivalent to 0. Okay, or true is also known as high and false is known as low. So let us write the all different names of the same thing: true and false, or 1, or high, false is equivalent to 0 or low. Okay, all these mean the same thing. Then we move on to logical operators. Now, logical operators are of three kinds. One is logical or, logical and logical not. Or, and not. And how are they written in Blue Java? These are two vertical lines, two ampersands, and this is one exclamation mark. The brackets are optional. Okay, you don't give brackets. So let us do the logical or first. How do you write it? You have two conditions and you compare them. Logical operators are basically to study the uh, compare two relational operators. Okay, so suppose you have two expressions with relational operators and you want to see whether they both are uh, true together or any one of them is true. So you basically analyze a situation. Okay, you are comparing but you want to study the comparison, then we will use the logical operators. So this logical OR is used to combine two conditional expressions, and if the result is true in any one of them, then the final result is also true. So let us see, for example, um, let us take an example: A less than B or A greater than 50. Now, when you're using logical OR, you will have to study that whether this is true or false, and same for this logical operator also. Suppose A is equals to 49 and B is equals to um, 50. Okay, now is A less than B, so this side is true, and is A less greater than 50, so this is false. So what will be the final output of this logical operation? If any one of them is true, then the answer will be true. The final result will also be true. But if this is false and this is true, then also it should be true. The final result should be true because at least one of them must be true. If both are true, then also it will be true. But if both are false, then the final result will be false. Okay, so this is how the logical OR works. Okay, it compares one or more relational comparisons and gives you the answer. So suppose instead of two operations over here, I have three operations. So if it is true, 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 then it will give true. If it is false, 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 then only it will give the false. But if any one of the three, any one is true, then the answer will be true. One can be true, two can be true, three can be true, but at least minimum one true must be present for the final output to be true. Next, we move on to the logical AND, which is written with two ampersands. Now, logical AND is a little strict in the sense that for a true final outcome, all the relational comparisons must be true. If any one of them is false, then the final outcome will also be false. So the AND operator results in true if all the expressions which is comprising, constituting that expression is true. Okay, so suppose I have A is equals to 13, A is equals to 13 and B is equals to 15 and C is equals to 14. Okay, so if I have A greater than B and B greater than C, suppose, let's see what happens. Is A greater than B? No, false. Is B greater than C? True. But since one false is there, the final outcome will also be false. So, not a single false can be there to get a final true outcome. Okay. So, this is possible only when all the conditions are true, then only the logical AND will give you a true. Even there, if there are 100 comparisons, if there are 100 logical operations like this and all 99 are true and one is false, then also the final outcome will be false. So not, don't keep the notion that only two comparisons are there. There can be n number of comparisons, but all must be true for the final outcome to be true. So with this, we have come to the end of Unit 2. Go through the chapter and read through the chapter and follow this note. And then we will send you some more explanation of unary and binary increment decrement operators. Thank you.